Alrighty. Find the range R of a projectile whose initial velocity is 10I plus 7J and whose height above the horizontal displacement is 3/4 R. Now, if you imagine that this is your XY axis, right? And just for argument's sake, this is where you start, this is where you finish, and I was going to grab this is my R value. Okay. I then have to make another line in the middle that's 3/4 of the blue length. Does everybody see that? So 3/4 of the blue length. I'm just going to try and do it by eye here, around there. What would that mean? Quite a steep throw. Would you agree with that? Well, usually quite a steep throw. Not that steep, but steep enough. Right? What happened if it was like a quarter, or what would that tell you? Very low and sharp, doesn't it? So there's a bit of indication of what you'd be doing. If you ever ask for angles down the line, not in this question, but in other questions, that sort of gives you an inclination of what angle you'd be using to get it. Okay? Whether it be really acute or a bit closer to 70, 80, 90 degrees. Okay? Now, we're going to do what we always do. We're just going to go for Vx, which is 10I. We're going to go for Py, or just 10 simply. Py is going to be 7 minus gt, so minus 9.8t. Sx is going to be 10t. And then Sy is going to be 7t, half the second one, 4.9t squared. Right. What do we know about the range? What's guaranteed at the range? What's guaranteed? Sy equals 0. So let's start off with that. So let's factorize out the t. And we get 7 minus 4.9t. T equals 0, which is the green point. We knew that already. And then you get 4.9t equals 7. 7 divided by 4.9 is 10 over 7. So t, time of flight, or TOF as I call it, is 10 over 7. Or essentially t equals 10 over 7. Okay, we all okay with that? Now we're going to find the R value. So how do you find the R value? The blue line is what type of length? An Sx or an Sy? An Sx. So you do Sx equals 10 multiplied by 10 over 7. Sx is 100 over 7. Is that okay? Oh, sorry guys, I think I read the question wrong. Of course I read the question wrong. I was asked for the height 3/4 of the way along the road, so sorry, just give me a second, right? Haven't made a mistake yet, which is a good thing. So everything you see there is perfect, but I actually misinterpreted the question. I was thinking of another question. Here's what you need to do. You basically go 3/4 of the distance along, and what you're looking for is the height at that point there. 3/4 of the way along, or you're looking for the height above ground. Is that okay? So, sorry guys. So what I'm actually looking for is the height above ground at this point here. Okay? So, 3/4 of R. I can find 3/4 of R, can't I? Because I know R is 100 over 7. So that'll be 3/4 of that. Plus 3/4 of 100 will do you nicely. 75 over 7. So what the question really is when you're at displacement of 75 over 7, so what is your height? Height is an Sy equation. Would you agree with that? Up and down is Sy. You need a time to find this. You need the time to make it work. Okay? To me, 3/4 of the distance would be 3/4 of the time. But look, let's just be thorough. We know that Sx equals 75/7. We know that Sx equals 10t equals 75/7. And then just divide, to get the time, it's 75 divided by 70, which is 15/14. 15/14. Which is 3/4 of our time of flight. Time of flight was 10/7. 3/4 of our time of flight is 15/14. So I just proved it anyway, but it probably wasn't necessary. Now, you need to find out Sy. So what are you going to do then? 15/14? Yeah, put it into the Sy equation. And you're going to get 7 times 15/14 minus 4.9 15/14. Then we get 15/8 or 1.875. Put it all into calculating at 1.875 meters. Cool. Alright. Alright guys. Factorize this. You're going to get 7t squared multiply the 7 by the 500 and you get minus 3,500. Break that up into its factors. You get a 50 and 70. So I'm just going to do it like this. Minus 70t plus 50t minus 500. 7t into 7, into t minus 10 plus 50 into t minus 10. And you should get 7t plus 50 and t minus 10. That should be it. Okay. So, a cannon fires a cannonball from the top of the cliff, which is 350 meters above ground. And this time it fires it upwards, so that's different than the last one. Now, still saying the top of the cliff is 0, 0. And you're going to fire it slightly upwards. Fire it like so. If any of you already have it out, I'm on to question 7 next. So, actually, question 9. Go for 9 next, okay? So here, get on the rest of the side, just go there before me. Alright, so that's roughly what we're doing. And this is going to be minus 350. So, Px equals 10. Py equals 14 minus 9.8t. The goal of the question is to find how far along we went. So we're trying to find the range, the blue length. So Sx equals 10t. Sy equals 14t minus half t squared. Now, Sy equals minus 350. So 14t minus 4.9 t squared is minus 350. Alright. Divide everything by 4.9. I think I'm going to get minus 1t squared. I'm going to get minus 500/7. You can do the minus b formula if you want, it's no big deal. 20/7. And then if you get a common denominator, you're going to end up with that quadratic they asked you in part 1. The quadratic you did in part 1, you're going to end up with that in a second. So we're going to end up with 20 minus 7t squared equals minus 500. And you're going to end up with 7t squared. Where's the t gone? Oh, there's the t. Plus 20t plus 500. No, minus 20t. Not that either. That's plus 500. That's minus 70 plus 20. 0. By both sides by negative. There we go. That's what we had at the start. So it's 7t plus 50, t minus 10. And you get t equals 10. You can't have negative time, so t equals minus 50 over 7 is no good. So next thing you need to do is find the range. Range is an Sx value. Sx value is 10 multiplied by t. 10 times 10. And we get 100 meters. Happy days. Right, you're on question 9. Alright, first question is, both starting to get old at this stage. It's the same question, isn't it? So, it's 0 minus 78.4. And you get fired horizontally and you fall to the bottom. Your phi x is 98. Your phi y is 0 minus 9.8t. Your Sx is 98t. Your Sy is 0t minus a half, so 4.9t squared. Now, Sy, at time of flight, Sy equals minus 78.4. So minus 4.9t squared equals minus 78.4. 78.4 divided by 4.9 goes 16 times. T squared equals 16. T equals 4. Is that all mass? Alright, done. Alright. Now, where the real money's made is you're going to have to adjust your angle. Okay? So initially we fired it downwards. Okay? And it went down this way. Next thing we're going to do is we're going to adjust our angle upwards to 30 degrees. And we're going to fire it up this way here. Now, what you're going to have to do is you're going to have to use basic trigonometry to change you're going to change your phi x and phi y values initially. So here's what you're going to do. You're going to make yourself a triangle. It's going to be 30 degrees here. And the hypotenuse is going to be 98. There we got that. So you have a new triangle. And you're shooting up and to the right. And what you have there is you have 30 degrees here. 98 meters per second. So we have to find out what x and y are. Or technically speaking, it's uy and ux. The initial speed along y and the initial speed along x. Alright, cos 30, which is adjacent over hypotenuse, will be ux divided by 98. Therefore, ux is 98 cos 30. And 98 cos 30 is 49 root 3. Same trick for sine 30. Sine 30, which is opposite divided by hypotenuse, which would be uy over 98. And then uy is going to be 98 sine 30. And 98 sine 30 should be 49. Yeah, it's 49. So, you go back to your equations that we used earlier for the really easy part. Now, what do we change? Going to change these parts here, okay? So, Sx is now, or sorry, Vx is now 49 root 3. Py, lads, 49 minus 9.8. T. Sx is 49 root 3 times T. And finally, Sy is Sy 49 root 3 T minus 4.9 T. Right, I'll pause it there. For Sy, it's 49, not 49 root 3. Now, by the time we'll now take corrected one decimal place. Alright, we're going to use the Sy equation again, aren't we? 49T minus 4.9T squared equals minus 78.4. I think I'll divide everything by 4.9. I get 10T minus T squared equals minus 16. Is that correct? Yeah. Then T squared minus T squared plus 10T plus 16 equals 0. That explains it. And T squared minus 10T minus 16 equals 0. Alright, you're going to have to probably do the minus b formula here, because I don't think it's going to factorize properly. I was thinking 8 and 2, but obviously it doesn't work in this case, so let's try this out. Now a equals 1, b equals minus 10, minus b equals plus 10, c equals 16. Do the minus b formula. 10 plus or minus the square root of b squared minus 4.8 times c. All over 2 times 1. What do we get? And we just get 11.4. You don't have to worry about the negative value, do you? No. Yeah, the other one's a negative value, so you don't need it. The other one's minus 1.4, so you don't need it. Alright, 11.4 seconds and we're good to go. Ready to move on? In your Px equals 12, Py equals A, Sx equals 12T, Sy is Kt, oh sorry, K minus 9.8T, because Py is going against gravity. So Kt minus 4.9T squared. Everybody get those four formulas? Alrighty. Now, what you need to realize is that the times are equal to each other when Sx equals 30 and Sy equals 9.375. Both times are identical. So they're the same time. Alright? So on your paths, when you're going through up and down, I don't know whether it's on the way up or the way down, that's irrelevant. But what I'm basically trying to say is that the point 39.375 is on your path, and it takes place in the same time frame. So, you can say that Sx equals 30, and this means that t will equal 30 divided by 12. 30 divided by 12 is 2.5, isn't it? Alright? So what happens when you insert 2.5 into Sy? What has to happen? What does the answer have to be? Has to be 9.375. So 4.9 by 2.5 squared is 30 times 625. That's 2.5k. That equals 9.375. Add on your 9.375. 40. 2.5k equals 40. And then 40 divided by 2.5 equals 60. Okay with that? Now, see this blue bit here on the side? That means you're entering honors territory now, okay? So, what we did there was a typical past question, past level question, but now we're into honors level now, okay? Here we go. Alright, the maximum height and range of a projectile are equal. Find the angle of projection to the nearest degree. Better. So, this is the one I was thinking about earlier. So, if I do a circle, not a circle, yeah, I suppose we could do a circle, it would be easy to draw it out. So, yeah. No. I'll give it a circle. There we go. Right, so this one's my range. The blue one's my range. Then I'm going to take it to the halfway point here. Move the circle to the halfway point if I can. About there-ish. And you can be my... The range and maximum height are equal. Ouch. So, that looks longer, doesn't it? Alright, never mind. I forget the circle. They're both, should work, but they're both the same. Right? And it basically goes like this. Up, back down again. So, I'm thinking for that to happen, it's got to be a steep enough throw, doesn't it? Okay, so let's find out. Basically, the height equals r, and the range equals r as well. Okay? So, let's think about this logically here, okay? We have no Vx and we have no Vy, do we? Alright. I'm going to start bringing in angles into this now, okay? So you're going to have to excuse me for a second. This is where we move on to new territory, okay? So, what I say is we fire it up with generic value u. I haven't got a clue what u is. I break it up into two components. What two components can I break it up into? Usually ux and uy, yeah, no bother. I'm not going to use ux and uy though, because I'm going to find out what they are. We're going to call it angle alpha, like a curly A, okay? Greek alphabet. Now, can anybody tell me what would the adjacent be? Cos alpha equals, for argument's sake, call it x. Would equal x over u. So what's x? X is u cos alpha. Are we cool with that? Can anybody predict what the other one's going to be? The other's going to be u sine alpha. Okay. If you want to cut to the chase, sine alpha would be y over u, and then y would be u sine alpha. Are we cool with that? Let's make our equations. So, equation wise, let's start off with dx. What's dx, lads? Dx is u cos alpha. Dy, u sine alpha minus 9.8. Okay, better. Sx. Yeah, now, because cos alpha and sine alpha are functions, yeah? So, I never write u cos alpha t because sometimes the t gets stuck into the angle. So what I'll write is ut cos alpha. I'm getting the t away from the trigonometric function. Don't want that anywhere near it. I've seen some weird mistakes in the past, so this prevents it. Okay? Can I tell you what sy would be then? Ut sine alpha, because it's u multiplied by t, so it's ut sine alpha, yeah? Yeah. We're still doing the same trick, aren't we? Add a t onto the first part, half the second part, and add another t. Still the same trick, okay? Now, here's where things get interesting. Alright. Let's find the time of flight. Let's find how long it's in the air for. How do you find the time of flight? What's guaranteed about the landing part? Put this equal to 0. Let's find out what we're doing. So, factorize out what letter? T. Factorize out t, and what you get? U sine alpha minus 4.9. Okay, t. And then t equals 4.9 t equals u sine alpha. And then t equals u sine alpha divided by 4.9. If I was to write this down, would this be the same thing? U sine alpha divided by a half gravity. And then I'd argue that that's the same as 2u sine alpha over g. They're actually the same thing, aren't they? So some of the solutions you might see done at home, I pretty much give up on 9.8 and 4.9 now. I start using gravity instead. Is that okay? So, just to be consistent with what I've done in the past, here's what we're going to do. That's now gt, and that's a half gt squared. That's a half g. That's a half g. And our actual answer will be, is everybody happy with 2u sine alpha over g as your time of flight? Because it will be a half gt equals u sine alpha, and then t equals 2u sine alpha over g. Okay, that's the way it's going now. Starting to honours math drifts more towards using g than 9.8. Okay. Now, how do I find the range? Anybody, how do I find the range? Huh? Sx, so what's Sx? U by 2u sine alpha over g. So what's the Sx value then? How many u's do I have? Yeah. Sine alpha, cos alpha, all over g. You haven't made a mistake, that's standard, that's perfect. Okay? Now, a quick cheat for us is that we know that the maximum height and the range are equal, don't we? We know they're equal. Now, what's guaranteed about the range? The range is, so what's guaranteed about the maximum height? By must equal 0. So what does that mean? This here equals 0. Tt equals u sine alpha. T therefore equals u sine alpha over g. Was that any surprise to us? Why was it no surprise? Did you even have to do that? Why not? It's just half the time of flight, isn't it? It's half the time of flight. Now, next question is, how do I get a SY? How do I get the maximum height? What do I do now? What do I do to get the maximum height? Sub into SY, because SY is vertical, okay? So we're going to sub into SY. So, let's do this. SY is what, guys? So, U by U sine alpha over G times another sine alpha minus a half. Oh god, look at this. G. Now what do I have to do with that yellow bracket? I'm going to have to square it, haven't I? So I'm going to square it out. U squared sine squared alpha over G squared. Now here comes the fun part. I'm still hanging on to my range. My R value is this here. That's pretty important. I'm going to move it all down here and make it a bit smaller. Okay. Alright, let's give a bit of room to work here. Now, U squared, it's all going to come together literally in a second. I know you probably can't see it with you. Everything's just going to cancel and you're just going to be left with tan alpha in about 30 seconds. Right. What happens here? G on the bottom, G on the top cancels with G on the bottom. And we're left with minus U squared sine squared alpha over 2G. What can I do over here? Then what's my answer? Two of them take away one of them. Just one of them, isn't it? Now, here comes the fun part. We just got the maximum height, but we're told that the maximum height also equals the maximum range. So the two of these formulas equal each other, don't they? Now, what disappears? Anybody? G disappears. One of the sine alphas disappears. The U squareds disappear. Now, there's a formula that you have to know off by heart. Tan x equals sine x divided by cos x. Just accept it for now. Works every time. Okay? So, see the cos alpha on the right? It's been multiplication on the right, so when I bring it to the left, what will happen? Will turn into division, won't it? So sine alpha over cos alpha equals 2 times 2, 4. What do I change sine alpha and cos alpha into? Tan alpha equals 4. Do you know what tan alpha means? Tan means opposite divided by adjacent. This means our height is 4 times longer than our throw will be 4 meters up for every 1 meter across, which as predicted is quite the high throw, isn't it? Let's find out the angle. It's going to be something insane. Tan inverse 4. So when you tan inverse 4, you're going to get 75.96 degrees. Okay. Now, just while we're here. So when you go to the YouTube channel, what you'll see is on the 5th year applied maths playlist, you'll see 3B questions 6, 10, 12, 14. You'll also see 15 and 16 there as well. They're the questions you're going to do for tonight. So, what do we say? 6, 10, 12, 14, 15, and 16. Okay? They're due on Wednesday. You'll have no homework on Wednesday because you'll probably want to study for your test, which is on linear motion, next Friday, October 23rd. Alright, enjoy. What do I do? 13, 11, 5, 9, 11, and 13.